Okay, everybody, it's good to see you again. We're going to move forward into Chapter 7. Just a quick review of where we have been and where we are going to go today. We've covered 7-1 and 7-2. 7-1, we did two techniques: factoring out the GCF and completing the factorization. Secondly, taking a polynomial that has four terms and factoring it by grouping. And then in 7.2, we moved from a polynomial that had four terms to a polynomial that had three terms, trinomials. And in 7.2, we factored a trinomial where the coefficient of the quadratic term was 1 and the sign of the last term was either positive, which was letter A, or negative, which was letter B. Now in 7.3, we're moving to the second style of trinomial. The second style of trinomial is exactly what 7.3 is entitled. Factoring trinomials where the coefficient of the quadratic term is not 1. Example: 8y squared plus 22y plus 5. Quadratic term, linear term, constant term. Note, the coefficient of the quadratic term is not 1. It happens to be 8. Now, want to mention this before we get into the process that's going to be shared. We're going to share a process of how we can take a trinomial of this type and factor it to its two binomial factors by using a sketch, by using a visual aid that will help us come up with the binomial factors. But I want to say this carefully. You do not have to follow the procedure that I'm going to be using. If you've already established a procedure for factoring these kinds of trinomials, and you remember what that strategy or set of steps are, you go ahead and use them. Some people will use trial and error. Some people will use another kind of a sketch. I use a sketch, and I think it's good. And if you have been away from this material, then I think this process that we're going to show is going to be a nice process. The procedure of factoring these kinds of trinomials is called the AC method. AC comes from actually the type of trinomial that we're going to be factoring. It's called a quadratic trinomial. And a quadratic trinomial that is written in standard form is this form: ax squared plus bx plus c. Now, it might be hard from your home to see that I colorized the coefficient of x squared, a, I colored it in purple, and also the last term, which we ordinarily commonly call the constant term, I put it in purple as well, the c. That's in part where the AC method is going to be used. This is the standard form of a quadratic trinomial. Here's the quadratic term, there's the linear term, and there's the constant term, or just oftentimes referred to as the last term. The a is the coefficient of the quadratic term, and the c is the coefficient of the last term. It's often a constant term, but it might not be a constant term. The c is the coefficient of the last term. The a is the coefficient of the first term, or the quadratic term. Now, here is the principle behind the AC method. And I'll make use of this trinomial right here to make the point. You kind of want to stay close to these next few words that are going to come out of my mouth. When we use the AC method, we're going to turn the trinomial into a polynomial that has 4 terms. And then we're going to factor by grouping. Let me repeat it again. To use the AC method, we're going to rewrite the trinomial into a polynomial that has 4 terms. Here's the mechanics of how it's going to be changed. We will leave the quadratic term, or the first term, as is. We are not going to meddle with it at all. We're not going to change it at all. Secondly, the last term, we're not going to change it at all. The first term and the last term, they will remain the same. It will be the middle term that we will split up. We're going to split up the middle term into 2 terms. Those 2 terms, when correctly added together, will give us the middle term. The middle term is going to be split up into 2 terms. So let's count. 1, he stays the same. 2 and 3, the second and the third term, will be here. And the fourth. He stays the same. He stays the same. The middle term is going to be busted up into 2 brand new terms. And those 2 terms, when correctly added together, will still equal 22y. Now here's the device that we're going to use to factor these kinds of trinomials. Some people will use an x. As a matter of fact, quite a number of people from the past have used an x design. Some people use, I'll put it over here, some people use what they commonly refer to as an eye chart. It's the same thing as the x, it's just a different look. Now I'm going to erase it. I kind of use the x. And people, here's what I want us to be able to gain initially from this structure. I'd like you to look at this visual and kind of correlate it to the face of a clock or the face of a watch. Up here in this top region right here, think of this as 12 o'clock, because that's where the 12 would be on the clock. Come down vertically straight down where you see the AC. This would be 6 o'clock. 12, 6. Over here, you know it would be 9 o'clock. And over here would be 3 o'clock. If you don't want to make references to the time of day of what I've just said, fine. Now, The 12 o'clock region is reserved for the middle term. So in a moment, right inside here, we're going to put a positive 22y. 12 o'clock region is reserved for the middle term. The 6 o'clock region is reserved for the answer that we get when we multiply A times C. Now remember that A is the coefficient of the quadratic term, so your A would be 8. And the C is the coefficient of the last term, and so the positive 5 is your C. The 6 o'clock region is reserved for the answer that we get when we multiply A times C. Positive 8 times positive 5, and in a moment he's going to be 40. The 9 o'clock region and the 3 o'clock region are going to be reserved for the two brand new terms of which the 22y is going to be split up for. The middle term of 22y will be written here. The 9 o'clock and the 3 o'clock region are reserved for the two brand new terms that when added together will give us this middle term. It's a little device that I think will be nice to make use of. Now I'm going to ask Kristen to kind of bring down this camera over here, because here are some key principles that we're going to follow as we fill up 9 o'clock and 3 o'clock and then move into our factoring by grouping. These statements that are down here are really not new. We use these principles in 7.2. Here's the prerequisite for the AC method. If A multiplied by C is positive, if AC is positive, I want you to memorize these two key characteristics. If AC is positive, whatever the sign of the middle term is, it's going to be taken for both 9 o'clock and 3 o'clock. If AC is positive, if this number is positive down here in 6 o'clock, both 9 o'clock and 3 o'clock will take the sign of that middle term. And the second thing that you'll see me do next to that design in a moment is really add. These two terms, when we situate them in there, they will have to really add together and give us this middle term. That's, in principle, what that is saying. If A times C is negative, if the number in the 6 o'clock region is negative, the first thing that will be true is the 9 o'clock region and the 3 o'clock region will have different signs. One of the regions will be positive and the other one will be negative, and it will not make any difference which one you let positive and which one you let be negative. I will offer a strategy, but either one of them can have either one of the signs. Plus, minus, minus, plus. If AC is negative, that will automatically mean that the 9 o'clock region and the 3 o'clock region will have to have different signs. And secondly, really subtract. If we subtract these two brand new terms from one another, the answer that we must get after we subtract them must again be the middle term. Now, let's show you by actually doing number 1. I'll kind of leave that there. Matter of fact, I'm going to erase this part right here. And I'll put this X right up here. And I'll just rewrite middle here and AC there. But I'm going to use this space right here to actually do the work. Okay. Now let's start with number 1. Now, people, again, don't jump into the situation and look at this coefficient and say, oh, that coefficient is not 1, so that means I'm going to use AC. You are right. But if this trinomial has a GCF, remember, we have to stay with the techniques that we've already done. We need to start by looking at the polynomial and seeing if it's got a GCF. 8, 22, and 5, nothing. That's the smallest of the 3 numbers, and 5 doesn't go into either 8 or 22. Do they all have Y's? No. Number 2, next step, does it have 4 terms? No. Does it have 3? Yes, it does. But we're not going to make our 2 binomial structures here because the coefficient of the quadratic term is not 1. If it would have been that, I would have made the binomial houses right away, but it's not. So now we're going to go into our structure. Up here at 12 o'clock, put the middle term, the entirety of the middle term. Six o'clock, multiply your A times your C. They're both positive, positive 40. Watch as we revolve here. If the sign of AC is positive, the middle term sign is going to be taken for both of our brand new terms. So just go right up here to your middle term and you see that it's positive. Then that means 9 o'clock is going to be positive and 3 o'clock is going to have to be positive. And now we do this to get our terms. We need to identify 2 factors of your AC number, 2 numbers that multiply together and equal 40. And those same 2 numbers, when really added together, give us 22. We need 2 factors of the AC number, which when really added together, give us the coefficient of the middle. And we should see that 2 times 20 is 40. And 2 added to 20 is 22. 2 and 20 would be our 2 numbers that we're going to use. It can't be 8 and 5. 8 times 5 is 40, but 8 added to 5 is not 22. But 2 and 20 work. So we come over here into the 9 o'clock region. And in the 9 o'clock, you either will write a positive 2y or a positive 20y. It doesn't matter. I'll go ahead and write a positive 2y. And in 3 o'clock, a positive 20y. Now let's check. 2y really added to 20y, bullseye, the middle term. And if we multiply positive 2 times positive 20, we get a positive 40. So now we build into our factoring by grouping situation. We're going to create 4 terms. Like I already said, the first term remains the same. Bring it down. It's the middle term that's going to be split up, and here's the split. I ordinarily begin with 9 o'clock and then bring in 3. If you want to bring in 3 and then 9, it doesn't matter. I'm going to bring in 9 right here. Then 3. And then bring down the last. This polynomial that I just wrote is the same as the one right above it. It's just been converted into a polynomial that has 4 terms. Now we're going to take this polynomial and we're going to factor it by grouping because it now has 4 terms. And people, one thing that you will not need to worry about when doing AC, you do not need to check your ratios. The ratios will already match. So, just tuck the front pair and tuck the back pair, and remember that there's an addition sign in between. Go to this front pair and pull out its GCF. Both of these terms not only share a 2, they share a y. So pull out a 2y, and let's divide twice. 8y squared divided by 2y would give us 4y. And a positive 2y divided by a positive 2y would give us a positive 1. Come over here. Pull out the GCF, a positive 5. Divide it twice, 20y divided by 5. And positive 5 divided by positive 5. And now we complete our factorization. Here's our first term. And there's our second. And they both contain a common binomial factor of 4y plus 1. So we pull out that common binomial factor of 4y plus 1, and the other factor will be made up of the turkey and the gravy. People, if you foil these, which I will do because it's the first one that we're doing, if we foil those 2 binomials, we should get 8y squared plus 22y plus 5. 8y squared. There's a 20y. There's a positive 2y. 20 and 2 gives us the 22y and the positive 5. Again, if you don't need to show this process, don't. You're not required. But if you've been away from it, it's a good way. Okay. Let's take a look at number 2. (10x squared) negative 9x plus 2. GCF first. I believe the answer is no. I'm not going to say anything more about it. We've done this GCF stuff. I'm not going to say anything more. No. Next question, does it have 4 terms? No. Next, is it a trinomial? Yes. Is it AC? Yes, it is AC. Because the coefficient of x squared is not 1, it's 10. So it's AC. Middle term, negative 9x. AC, positive 10 times positive 2. positive 20. All right? Again, look at the sign of AC. If it's positive, the middle term sign will be taken for both 9 o'clock and 3 o'clock. He's positive, that sign wins for both. And so does this win for both. We need two factors of 20 that when really added together will give 9. 5 times 4 is 20. 5 added to 4 is 9. 5 and 4. 9 o'clock, doesn't matter which one. A negative 5x. A negative 4x. Negative 5x added to negative 4x, negative 9x, negative 5 times negative 4, positive 20. Let's build it in. Bring him down. The quadratic remains the same. The negative 9x is being split up. We've got him. Negative 5x, negative 4x, bring down the last term. Tuck. Tuck, keep him negative. Just stick a plus sign in there. Pull out the GCF. They both have a 5 and an x. Complete that little factorization. 10x squared divided by 5x would give us 2x. Negative 5x divided by a positive 5x. Negative 5 divided by positive 5, a negative 1. The x's go. The second one, he begins with a negative. This house begins with a negative. You're going to have to pull out a negative and a 2. Negative 2. Divide twice. Negative divided by negative. Positive divided by negative. There's the common binomial factor. Bring it down. And then bring in that turkey and gravy. And we'll have 5x minus 2. And we've got our binomial factors. And people, you go right ahead and FOIL it. And you're going to get 10x squared minus 9x plus 2. You'll get it. All right. Now, the third one has just a little tweak to it. Not much, but a bit of a tweak. Number 3. 12x squared. Negative 22x plus 6. GCF. Very much so. 12, 22, 6. They're all even. Let's check the 6. 6 doesn't go into 22. So we have to search for a factor of 6 that is smaller than 6. There's 3 and 2. 3 doesn't go into 22, but 2 does. 2 goes into all of them. Now here is what we want to do. Before I go to this step, when we take a 2 out of this trinomial, the coefficient of this quadratic term is going to become a 6. Because 12 divided by 2 is going to be a 6. And that 6 is going to demand that we use AC. So here's what I'm going to suggest that you do. When you pull out that GCF of 2, instead of going to a typical parenthesis house, why don't you consider changing it to a bracketed house? I think the bracket will pay off. Now let's divide all 3 of those terms by 2. Look at the trinomial that is in the bracketed house. The coefficient of the quadratic term is not 1. That means we're going to use AC. And that means this trinomial that is inside this bracketed house is going to be converted into a polynomial with 4 terms. I used a bracket so that we could eventually use parentheses inside the bracket to do our factoring by grouping. So we can kind of get it ready. I'm going to bring down the 2, and I'm going to make the bracket and open it up just a little bit, because in a moment we're going to have 4 terms in here. Let's go to our AC. Middle term. AC. Positive 6 times positive 3. For the 3rd problem in a row, AC is positive. If AC is positive, he wins. The sign of the middle term wins for both 9 and 3. And so does add. It doesn't take brilliance. We need 2 factors of 18 that when really added together would give 11. 9, 2. 9 plus 2, 11. 9 times 2, 18. Negative 9x, negative 2x. Or negative 2x, negative 9x. It doesn't matter. Doesn't matter. All right, let's build it. Down. 9 o'clock. 3 o'clock. The last term. Tuck. You see, that's why I used a bracket. Tuck. Plus. Down. Bring him down. Bring the bracket. Let's pull the GCF out of this first house. 6 and 9, they both have a 3, along with an x. 6x squared divided by 3x. Negative 9x divided by a positive 3x. Over here, a little interesting little character here. He begins with a negative. We have to pull out a negative. The only common factor that the negative 2x and the positive 3 have, they don't both have an x, they don't both have a 2, they don't both have a 3, but they both have a negative 1. And that's what we're going to have to pull out, a negative 1. Make your house. Negative 2x divided by negative 1 would give us a positive 2x. Positive 3 divided by negative 1 would give us a negative 3. Here's that common binomial factor. So now we're going to put some things together and relieve ourselves of the bracket. Begin by bringing down this GCF that this whole process started off with. Bring it down. Then, next to that 2, pull out this greatest binomial factor. And next to that, bring in the turkey and the gravy. There would be the entire answer. Now, a caution before I erase it. Here's what sometimes happens on the part of a student and an instructor. They'll do all the process right, but when they write their answer, they forget to bring down that GCF. And they just show that. Well, that would be wrong. So you have to be careful and not be in that much of a rush when you're doing it. All right? Now, problem number 4, the sign of AC will now change. Number 4. 15m squared plus m minus 2. GCF, absolutely not. 4 terms, no. 3 terms, yes. AC, you bet your boots. Why? 15. The coefficient of the quadratic is not 1, it's 15. AC. Middle term. If you want to show that middle term like this, you just do that. Because that's what it is. Now AC. Positive 15 times negative 2. All right. If AC is negative, 9 o'clock and 3 o'clock will have to have different signs. One will get positive, the other will get negative. Now, I told you some minutes ago, it doesn't matter where you put the positive and negative. But here's a suggestion. It is not a demand, it's a suggestion. In the 9 o'clock region, always let the 9 o'clock region be whatever the sign of the middle term is. Let 9 o'clock be the sign of the middle. That will mean the 3 o'clock will get the other sign. And the other thing, I'll leave that word up there. Okay. Here we go. We need 2 factors of 30 that when really subtracted from one another will give us 1. Really subtracted from one another to give us 1. 6 times 5 is 30, and 6 minus 5 is 1. The bigger factor, the larger of the 2 factors, 6, 5. The larger one, 6. The larger factor always gets the sign of the middle. So the sign of the middle is positive. The positive will get the 6m. The 3 o'clock side will get the negative 5m. Let me run it again. 6 times 5 is 30. 6 subtracted by 5, 1. The larger of the 2 factors, the 6 is larger than 5. The larger factor must always get the sign of the middle term. So the 6 gets the positive 6m. The other side is a negative 5m. Let's test it. If you add a positive 6m with a negative 5m, you get a positive 1m. And a positive 6 times a negative 5 is a negative 30. We're ready? Down. Bring in 9. Bring in 3. And bring down the last. Tuck. Tuck. Plus. GCF. 6 and 15, they have a 3. And an m. Let's divide twice. Let's divide. Pull out a negative. They only have a 1. Negative 1. Negative divided by negative. Negative divided by negative. Winner. Wrap it up. Negative 18k cubed minus 48k squared. Positive 66k. Number 5. Let's start with GCF. Well, there is definitely a GCF. If for no other reason, there would have to be a -1 because he begins with a negative. So I'm going to bring that sign down right away, because we're going to pull out a negative something. Even if it's a -1, I'd pull out a -1. But you see, 18, 48, and 66, 18 is the smallest of the three. And 18 doesn't divide into either one of those. So you got to go down from 18 to the next lower number that will divide into 18, and I think that would be 9. 9 won't divide into either of those. So you got to go lower than 9. 6. 6 goes into all three, along with a k. They all have powers of k. We take the tiny one. I go with a bracket. Negative divided by negative. See, people? There's that quadratic, and that coefficient is not 1. Negative divided by negative. Positive divided by negative. Might want to just kind of double check to make sure that everything is okay. That's a negative 18k cubed. That is a negative 48k squared, and that's a positive 66k. Now let's move into our AC. Bring him down. Bring this guy down. We're going to convert this trinomial into a polynomial that has 4 terms. Middle term. AC. 3. There's your A. Times your C. 3 times negative 11. People, as soon as you see that your AC is negative, that means plus minus, minus plus, plus minus. But because the sign of the middle is positive, once again, I'm going to let 9 o'clock carry that positive and the other one carry the negative. Subtract. Subtract. Factors of 33 that when subtracted from one another will give us 8. Well, doesn't take a whole lot of time. 11 times 3 is 33, and 11 minus 3 is 8. 11, 3. The larger factor 11 gets the sign of the middle. Make sure you put that letter K next to that 11 there, next to that negative 3. Positive 11k added with a negative 3k, positive 8. Positive 11 times negative 3, negative 33. Let's do it. Down. 9 o'clock. 3 o'clock. And the constant. Tuck. Tuck. Plus sign. Bring down that negative 6k. Keep your bracket. Let's pull out the GCF. 3 and 11? No. But they both have a k. Make a house. 3k squared divided by k. Positive 11k divided by k. Here, he was a negative. Got to pull out a negative, and it'll be a negative 1 again. Negative divided by negative, a positive 3k. Negative divided by negative, a positive 11. There it is. Down. Bring in that common binomial factor of 3k plus 11 and pick up the turkey and the gravy, and you've got the completed factorization. Now we're going to share one more. It might rack the brain just a little bit as we do this one. I'm going to give a little bit of extra room. You never know what you're going to be confronted with when you are factoring a trinomial where you are using AC. Number 6, the final one, 10a squared, negative 31a, negative 14. GCF. Well, they don't all have A's. He's the smallest. 10 doesn't go into either of those. 5 doesn't go into all of them. 2 doesn't go into all of them. It's got no GCF. 4 terms? No. Trinomial? Yes. Are we going to follow AC? Bet your boots. Middle. And here's the reason. AC. Positive times negative. And he's up there. Let's establish some things. If AC is negative, the signs must be different. Because the sign of the middle term is negative, I'm going to elect to let 9 o'clock be negative and 3 o'clock be positive. I know this for certain. When we come up with the two factors of 140, that when subtracted from one another to give us 31, the bigger factor is going to get the sign of the middle. So the bigger number is going to go here, and the smaller factor is going to go there. Like we have shown before, you can make a chart and you can title it 140. And you can just begin to list the factor pairings of 140. And people, as you list the factor pairings of 140, take the pair of factors that you get, subtract them from one another, and you have got to get 31. Obviously, no. Absolutely not. Now, 3 can't go into 140 because if you add the digits up, 1 plus 4 plus 0 is 5. And 3 doesn't go into 5, so it can't be that. So we go to 4. And 4 is going to be able to be divided into 140. And I think we'll get this. 35 minus 4. 35 subtracted by 4. 31. Process those. There's the bigger. He's going in 9 o'clock. He's going in the 3. Negative 35 added to a positive 4. Yes. Negative times positive. Yes. Down. In. In. Down. Tuck. Tuck. Pull out the GCF. Both 10 and 35, no, they don't both have a 10, but they both got a 5, along with an A. 10a squared divided by 5a. Negative 35a divided by positive 5a. Pull out a positive 2. 4 and 14 have a 2. That's it. 4a divided by 2. Negative 14 divided by 2. There's our winner. Write down that common binomial factor. And the turkey and the gravy. We have our factors. there's 7-3. And folks, I hope that I can say this to you. This should be very clearly seen from this lecture. We've done a total of 6 problems, and you should walk away from this video saying, I got the tiger by the tail. I know what I'm doing. I know how to do now this style of trinomial. Now once again, if you don't have to use it, don't use it. What matters is that I get this, that we get this. If you don't need to use this, and you can go from the trinomial right down to your 2 binomial answers, you do that. But we've given you a means of getting the answer. Now 7-3 is done. I'm letting you know in the days upcoming, very likely tomorrow, we will move into 7-4. And 7-4 is entitled Special Factorizations. It will be the last section of factoring techniques, and we will be doing 3 additional types of techniques. One of them is a special trinomial, and the remaining 2 will be binomials. And then the factoring techniques will be done, and we'll move into the latter parts of Chapter 7. But we'll say goodbye to you right now. Hope you are all doing well, and you're safe with your folks. And we'll say goodbye to you, and we'll resume again. You take care. Bye.